Hey guys, today I got a little project for St. Patrick's Day. Uh, I've got this little 3D printed Clover with a bit of electronic circuitry on the inside of it here. Got just some LEDs that do some random stuff. They're of course controlled by a microcontroller inside, and this is meant just to be clipped onto a shirt. So anyway, I'm going to show you how to build this today, and we're going to start by showing you what all the files, or what you have to do to some of these files in order to get them 3D print the way that it is on here, so the way that I made it work. I'll warn you, this video may jump around a little bit just because some of this footage is going to be filmed now after it's built, and some of the footage will be filmed during the build process, so certain things might not make a whole lot of sense, but they eventually will. But anyway, I'm going to go ahead and show you first off how I got these files and how you have to get them to print in order to get this to work right. So let's get to it. Alright, so for the first thing you'll need to print off here, go ahead and grab this Clover file right here. And basically the main thing that we're going to have to do with this is scaling it. So I scaled the whole thing to start with by 1.5, and that just makes it a little bit bigger and easier to put circuitry inside of it. Then I unlocked that, and whoops, didn't really mean to do that, but I unlocked that and scaled up in the z-axis by 7 times. Now I got 3 different Clovers in order to figure out the way that I wanted to do this and the size that I needed for it. But anyhow, over in the slicer settings, you're going to set your infill at 0%, and I'm using 0.2 millimeter layer height, but I don't think that matters too much, minus the fact that when you print this, you're not going to let it print all the way to the end. You're going to stop it. I stopped it right about layer 95, I think it was. So I stopped it right about here. And as you can see, you end up with a hollow Clover shape. And so if you just stop it there, you don't let it print the entire thing, you'll get this, and you got quite a bit of room in order to fit your batteries and the AT1085 microcontroller and all that stuff in here. Alright, so the next thing that I did, or the next part that you'll need, is actually the same part again, but you're going to change the scaling on it. You're still going to leave that 1.5 on the X and Y, but you're going to go down to 0.5. And this makes the lid of it, and that's for the LEDs to go through. Alright, so once you print that, give you some idea on how long that takes, how much film it takes. Mine ended up printing completely solid, by the way, which actually worked out quite nicely. But anyway, we'll get rid of that, and then the next one is the clip for the Clover. Now, I'll show you where I got these files from in a second, because I didn't design these. I just split them apart in NetFab. So anyway, with this one, I scaled this a little bit differently as well. I set this to 1.75, so it's just a little bit taller than it was before. So that's where it was. Since we made everything else bigger, I figured we might as well make that little shirt clip a bit bigger to make that work. One complaint I do have about this design is if you want to use it for a shirt clip, I'm not really sure what this was meant for, to be honest with you. But this gap in here is way too big in order to do that. And I'm only scaling this up to make it taller. I'm not changing this at all. So I ended up having to modify this a little bit, as you'll see later. And the last thing you'll need for this part I actually did design. This is a little button cell battery box here. And this one will have to be rotated, I think, in the x-axis by 180 degrees. You might want to scale it down to like 0.99 or something. Because some of mine were a little bit loose, and I think they could be tighter. And I'll show you how I make this work as a battery holder a little bit later.
Otherwise, you can get a normal CR2032 battery holder. I ended up taking the batteries out of one of those little one of the A23 battery cells, those little 12-volt ones that you see people online take apart, and you get a whole bunch of little tiny button cells. So that's what I ended up doing, and you'll see that later how I actually made that work. So anyhow, actually, I'm going to lock this and make them all 0.99. But anyway, I'll go ahead and show you where I got that Clover from real quick once I find that. Alright, on Thingiverse, I just used the search word Clover, and way down here at the bottom there's this Clover 4, and this is the file that I originally used. And as you can see here, this was one piece, as one STL file that had both the Clover and that little clip on it. So anyhow, I just split that in half with Netfab, so I didn't, so I could print them separately. There's not a whole lot of information about this thing, so anyway, I'll have like a remix of this on Thingiverse as well. I'll re-upload all my parts, and this video will be on Thingiverse as well. But anyhow, let's go ahead and start showing you how to build this thing.
Alright, so I've got a battery holder printed here. I'll just show you how these things go together. I've just got some 22 gauge solid copper wire here. It's tin copper wire. And we'll just take that and we'll strip off a decent bit of it. And these little holes in the back. Push the wire up through there and bend it around the side of the casing. Like so. Then you take a couple of these batteries that we pulled out of that little A23 battery a minute ago, and they fit nice and snugly in there. Now I'll admit it did take 2 tries to get this to actually work, but it came out quite nicely when it did work, so they'll actually stay in there quite nice. Alright, so I went ahead and I reprinted the little Clover here at that 1.5 times scale. It looks like everything will fit in this quite nicely. This might actually be to the point where you could stick like CR2032s in it. Is CR2032? Yeah, it is. Yeah, I guess you could fit some CR2032s in there, but unfortunately I don't have any full ones, so I'm just gonna have to deal with these little tiny things, but I think they'll work just fine. Well, I think these little batteries will probably last maybe 8 hours. I don't plan on keeping an LED on constantly. I know like a CR2032 you can just stick an LED straight on it without a resistor and leave it there for about 10 hours or something like that, and they last forever. But of course I'm going to have to run a microcontroller and that kind of stuff, but I think it'll work pretty good. Next thing I'm going to do is I'm going to put these in here upside down. The reason why I'm going to do that is A, the batteries won't fall out nearly as easy, and also that way there's not as much metal showing that could short out to the LEDs on the top part of this. So anyhow, all these will be stuck in here something like this. I'm going to solder these together so that they're all in parallel, and parallel will keep it about 3 volts, and it will be I don't know how much capacity that actually turns out to be, but it should be enough to actually last quite a while. Anyway, I see those batteries actually did fall out there. I might just some of these holders are a little bit looser than others. That just goes to show you that the tolerances of 3D printing aren't really that good. But I might just put a little bit of glue on these things just to hold them in there, because they seem to be making decent electrical contact. Alright, well that top part of this Clover prints, I'm going to go ahead and show you what I've done with this, because I don't think I've done that yet. I did end up printing off another one of these that was a little bit taller than the last one here. Partly because I accidentally hit this one with the soldering iron, partly because it really wasn't tall enough. You can kind of see the difference in the heights there. So this one ended up being printed to about 95 layers worth of plastic. So anyway, I've got the 4 little battery packs stuck in there. I'll try not to stab my camera with those pieces of wire coming out of there. But I've got those 4 little battery boxes stuck in there, as well as a switch put on the back. And that's pretty simple. I just melted a hole with the soldering iron in that and glued the switch down in place in there. Then there I've wired up an IC socket into there so I can plug in an AT-Tiny85. 4 white wires coming out of here will be for the 4 LEDs, and then the power wires are also hooked up into that chip or the socket there. So anyhow, now I'm waiting on that top piece to be printed so I can mount the LEDs in it, and then I'll get the LEDs mounted and print off a clip so you can hang this off your shirt, and that'll pretty much be it. Alright, so this is the lid for our Clover. I'm not sure how thick this is exactly. Or not. Yeah, it's like a 1/16 of an inch. But anyway, the way that I decided where to put the LEDs, these from the little valleys, I suppose you could call them, where the clover leaves are, in between those two are right about 2 inches. So I went just about 1/4 of an inch from each side of those. Again, I didn't design this model, so I don't really have any way of modeling holes into it. So we're gonna have to drill holes into it, and I've just got a 5mm drill bit here, which should fit the LEDs just fine. So anyway, that'll be the next part of this. I'm just gonna drill this out and I'll stick the LEDs into it and I'll be back. Alright, so here it is. I got the holes drilled in it and the LEDs pushed through. I'm gonna probably hold them down with a little bit of glue too, but yeah, they do stick out a little ways, but that's alright. It's not gonna hurt nothing. Anyhow, all the resistors are ground, and then the legs that are still sticking out of the LEDs are the positive ones, which will be hooked up to the white wires on here. So anyhow, I'm going to get to work wiring this thing up. Alright, so I've got it all wired together. I just kind of made an X with the grounds in the middle with the LEDs, and then wired all these white wires into the chip here. I've got the chip programmed, so you got this little switch on the back here. We'll go ahead and turn that on, and let's see, it's oriented this way only. Let's see what we get. Alright, so then that'll just continue looping. So this uses pretty much, well, I think it's 75% or 74% of the program space in the AT-Tiny85. So I may release a shortened version of this code that'll work on a AT-Tiny45 instead of the 85, because it does use, the way it is now, you will have to have an AT-Tiny85. But basically the last thing I need to do here is I've got to close this up. I'm just going to glue it together, because really hot glue is easy enough to get off if you just take a little bit of denatured alcohol here, and I've just transferred mine into this little squirt bottle thing. But if you take denatured alcohol, hot glue pops right off, so I'm not worried about it being stuck together permanently or anything like that. So basically, I've just got to get it to fit together, and then I've got to print off the little shirt clip, and it'll be done. Alright, so I've gotten the thing glued together. It's not the prettiest thing. You can tell it's just kind of hot glued together, and it's not perfectly lined up. I'm sure there's plenty of people that could have done that a lot better than I did, but Anyway, still works. Little switches on the back. The last thing I'm going to have to do is just print the clip for the back of this. So I'm going to go ahead and set a fixed exposure on the camera, and we'll have a look at this. Alright, so I got the camera turned down so it's basically black, but should be able to see what's going on here. And these are basically just random things that I kind of thought of while I was writing the code, so there's no real reason for any of it. And then it loops back around, so that's about all it does. About 35 seconds worth of code there, and it just continuously loops, of course. So anyhow, we'll go ahead and take a look at the code next.
While my printer warms back up so I can make that little shirt clip, I'll go ahead and go through the code and kind of show you what how this works and what everything does in the code. So these are the pin numbers that are just set up here, and I just set top right, top left. I shortened bottom into bot, so bottom right and bottom left. And those just declare the pin numbers. These declare the pins, all of our pins as outputs. And then we start going into this. So first off, it turns on top right, and then turns back off after a 1/10 of a second delay. Then it turns on the top left, turns it back off, turns on bottom left, turns bottom left off, turns bottom right on, turns it back off, and that's what makes that very first circular looking thing when the code first starts. And this rotates one way, and it does that 5 times, and it eventually switches and starts rotating the other way. And this is when it starts to rotate the other way. Then down here, we have where it starts to do the 2 LEDs on the corners are both on at the same time. So it turns on top right and bottom left, and then it turns it back off after a 1/10 of a second. Then it waits for a 1/4 of a second, turns on top left and bottom right, and then it turns back off after 100 milliseconds, and it waits a 1/4 of a second again. Then that repeats 5 times. And then now, instead of doing the corners, it's doing the top and bottom ones. So you see top right and top left are both on. Then it turns top right and top left off, and then it turns bottom left and bottom right on, then turns it off. Again, repeated for 5 times. And then this one starts doing the right and left going back and forth. So we turn right, or top right on, and top and bottom right on, and turn back off after that same 1/10 of a second, and wait a 1/4 of a second. Turn top and bottom left on, and wait a 1/10 of a second, and turn them back off again. So that gets repeated, and then this is the little sort of chasing scene that you see where there's 2 LEDs on, and they kind of chase each other, if you will. But this is all delayed off of a 1/4 of a second. And it starts with the top left one, then it turns the top right one on, then the top left one gets turned back off, top right gets turned on, or bottom right gets turned on, sorry. Then the top right gets turned off, and the bottom left gets turned on. Then the top left turns on, bottom right turns off, bottom right is on, bottom left is off, top left is off, bottom right's on, top right's off, and bottom left turns on, and that just repeats again 5 times. Then we go back to this where we reverse the direction, just like the very top part of that code. So this is basically the same, it just goes the other way. And then here, turn them all on for 50 milliseconds, and then turn them all off for 200 milliseconds. That repeats, I think, 16 times. It makes 4 seconds worth of flashing lights that probably could cause a seizure, which is probably not a good thing because those are pretty bright. That repeats quite a few times, and you end up with 647 lines of code in total. And as you can see, it uses 74% of the program space on the AT-Tiny85 microcontroller. So, quite a lot of code there. And when you're repeating 5 times, it could be, you could do that with like if statements and then just only write it once. But that makes it a little bit more complicated, and I mean, it's just easier to do this real simple, turn the LEDs on and off. So anyway, as I said, if I make a version of this that works on the AT-Tiny45, I'm probably just going to end up taking a lot of this code out, just so it fits inside the 45K of program memory that you have in the AT-Tiny45s. So anyway, that's a little look at the code. Hopefully I explained it good enough. I mean, it's pretty simple. It's just turning LEDs on and off. But anyhow, I'm going to go ahead and get that little plastic clip printed and glued back on to the Clover, and this project will pretty much be done.
Alright, so the clip has been printed and slightly modified. Now, the way this came off the printer, there's a pretty big gap in the, like these two ends here, and that just didn't work very well for a shirt clip. I kind of stuck it on my shirt, and it just was really loose, so I didn't really like that. So what I did is I took my fingers, I just pinched it like that, took a lighter, heated up this part here, and that bent back down, so now those ends are touching, and it actually makes a tight fit onto the collar of a t-shirt. So anyhow, it is a little bit deformed on this end now, but it doesn't really matter. No one's really going to notice that. But anyhow, last thing to do is actually stick it on our Clover. So we'll get some hot glue on that. And we'll stick it up toward the top as far as we can get it, really. It's probably the best bet, so it sits right on the shirt. Something like that should work pretty good. Alright, so go ahead and give you a little look at this finished product here. You've got 4 LEDs in the front. They are green LEDs there. They're clear and they're really pretty darn bright if you stare right at them, even though they're only running off of 3 volts worth of batteries in there, and they are on 220 ohm resistors as well. Trying to limit the current so those batteries last a little while, because remember, I pulled the little cells out of one of these A23 batteries, so kind of a cheap way to get a few little button cells. And the main reason why I used the little A23s is because I had those lying around and I didn't have any good like CR2032s or anything like that. So anyhow, I've got all the batteries taken out of one of these, and I rewired them so that they're at 3 volts instead of 12 volts, and hopefully give us a decent bit of run time. But put the little shirt clip on the back and the switch back here. If I push this up, the LEDs will turn on, and there we go. I'll just let this run through one more time just to show you. The main reason for this thing would be for St. Patrick's Day, when you're supposed to wear green. You know, why not wear a flashing green Clover, because that makes sense, I suppose. So anyhow, I thought that was kind of a neat little project. Files for this will be on Thingiverse, and that's about it for now, guys. So I'll go ahead and let you watch the time lapses that I got from printing this right now, and that'll be it.